Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stoliarov II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization.
Robots in space!
Hello everyone, I'm Mike DiVerde. I'm an aerospace engineer. Welcome to another edition of Robots in Space. Today I'm wearing my Delta II rocket shirt. First, let's locate the Curiosity rover on a false color topographic map of the entire surface of Mars. Look at the large black arrow pointing to the location of Gale Crater. This is where the Curiosity rover landed on Earth date August 6, 2012, which was Sol 1 on Mars for Curiosity. Now you see a close-up of the entire circumference of Gale Crater. The large black arrow now points to the elliptical landing site of Curiosity rover within Gale Crater. The landing site is on the crater floor, which is named Aeolus Palus. The center of Gale Crater is either called Aeolus Mons or Mount Sharp, which rises 18,000 feet above the crater floor. On the right, there is a map of the entire traverse of Curiosity since landing in 2012. Here's a selfie that Curiosity took on Sol 1126. This is a panorama video that was created using many individual photographs that were taken by Curiosity once it had ascended to a local ridge of Mount Sharp inside Gale Crater. The view is to the north, looking at the mile-high rim. Locations of the path that Curiosity took since landing in 2012 to the time of this panorama in 2018 are now indicated. This panorama gives an idea of the landscape that this rover has traversed in the first 6 years of its 12 years of travel. Now we will fast forward to the current location of Curiosity for an update. Curiosity is roaming Gale Crater, shown on the map of Mars, near the equator in the east. This is a photo from the mass cam on Curiosity on Sol 4338. On Earth, that's October 19th, 2024. The terrain has lots of rocks, which ultimately prevented an autonav. Here, because of the many large rocks in the terrain, there was a concern that auto-navigation would fail, which could position Curiosity in a bad orientation for the next communications window. The drive reached about 90 feet, whereas an autonav in better terrain might have been much longer, like about 160 feet. After the drive, we did a mass cam survey to observe soils along the traverse path. This image from Perseverance's right nav cam looks back along rover tracks from Jezero Crater. This image was acquired on October 4th, 2024, which is Perseverance's Sol 1288, at the local solar time of around 1 in the afternoon. Perseverance just keeps marching up the Jezero Crater rim. This steep ascent through the Martian regolith can prove to be slow driving for the rover, as the wheels can slip in the steepest areas. This is kind of like trying to run up a hill of sand on a beach. With every step forward, you slip a little way back down the hill. Driving through the Mount Rainier quadrangle, there is a relatively obstacle-free path to reach the crater rim, which is now called Summerlin Trail. Perseverance is trekking to the next waypoint near an outcrop of rocks called Pico Turquino, where it will undertake its next science investigations with the Pixel and Sherlock instruments. So what are Pixel and Sherlock? Pixel, P-I-X-L, stands for Planetary Instrument for X-ray Lithochemistry. Pixel is an X-ray fluorescence spectrometer to determine the fine-scale elemental composition of Martian surface materials. Sherlock, S-H-E-R-L-O-C, stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. Sherlock is an ultraviolet Raman spectrometer that uses fine-scale imaging and an ultraviolet laser to determine fine-scale mineralogy and detect organic compounds. Mars weather at Gale Crater. We're going to talk about Sol 4341, which on planet Earth is October 22nd, 2024. Curiosity is taking daily weather measurements at Gale Crater in the southern hemisphere of Mars, near the equator. At this location, it's currently late summer. On the Earth date of October 22nd, 2024, the high was 14 degrees Fahrenheit and the low was negative 71 degrees Fahrenheit. Mission overview for the Chang'e 4 lander and Yutu 2 rover. Yutu 2 is the robotic lunar rover component of CNSA's Chang'e 4 mission to the moon. It's launched on December 7th, 2018, and then made its first soft landing on the far side of the moon on January 3rd, 2019. Yutu 2 is currently operational. It's the longest lived lunar rover ever, now at over 2,000 Earth days on the moon. It eclipsed the previous lunar longevity record of 321 Earth days, which was previously held by the Soviet Union's Lunokhod 1 rover. Yutu 2 is the first lunar rover to have ever traversed the far side of the moon. The landing site is within the Von Karman crater, which is in the South Pole Aitken Basin on the far side of the moon, which was previously unexplored by landers. A recent update from this mission is that China's lunar rover sent home some of its latest images on the moon's far side. China's Yutu 2 rover has traveled over 1,613 meters on the mysterious far side of the moon as of Tuesday, and sent home the latest images that showed the lunar surface's diverse features. Today we're going to discuss a research paper that was published recently that combines data from the Chang'e 4 lander, the Yutu 2 rover, plus the American Lunar Reconnaissance Orbiter. And it has to do with lunar temperatures. I'm going to have some selected quotes from the paper entitled Analysis of Thermal and Dielectric Loss Features of Lunar Regolith Considering Real-Time Effect Solar Irradiance. The combination of solar irradiance and temperature data sets detected by orbiters can help explain the temperature variation and thermophysical properties of shallow lunar surface. This study develops a real-time effect solar irradiance ESI model that takes into account the influence of lunar topography and integrates it with a thermal model to simulate physical temperature variations within the von Karman crater. We then simulated the temperature data in the 4 frequencies consistent with the Chang'e 4 microwave radiometer and obtained the average ranges of dielectric loss. These findings provide valuable insights for analyzing lunar surface temperature and observed brightness temperature, as well as for inverting physical and dielectric properties of the shallow regolith, for example, dielectric loss. The lunar surface temperature, LST, and the thermal properties of lunar regolith are significantly affected by solar irradiance, the primary heat source on the moon's surface. Effect solar irradiance, ESI, received at the lunar surface is not only crucial for providing reliable data on sunlight duration and intensity, which is vital for selecting optimal landing sites for in situ scientific exploration, but also plays a key role in deciphering the thermal behavior of the regolith observed by orbiters and in constraining the physical and thermal properties of the shallow regolith. ESI on the lunar surface has been the subject of study for decades, particularly in the permanently shadowed regions of the lunar poles, which are of interest in the search for water ice. However, it is important to note that the surface and shallow temperatures detected by orbiters represent brightness temperatures, which should not be directly equated with physical temperatures. Although the Lunar Reconnaissance Orbiter Diviner Band 7 provides a reasonable approximation of the LST, and again, LST stands for lunar surface temperature. So here's my summary of why this is important for us to consider. LRO has been collecting data on the reflected light from the moon for around 15 years. These scientists have compared this on-orbit data with the Chang'e 4 lander's data from the lunar surface. This validates the data from LRO. One of LRO's specific instruments provides a good temperature reading for the moon's surface. Then this data can then be used to plan where to build sites and where to prospect for water ice. This is the reason why this paper is of interest. If you're going to build bases on the moon, if you're going to explore the moon, understanding what the temperature variation can be normally would be great. The moon has no atmosphere, therefore the temperature variations during a lunar day or a lunar night correspond to the solar irradiation that it has at the time. Now it's time for Martian sightings. In this segment, we're going to cover sightings of aliens, unidentified flying objects, and unidentified anomalous phenomenon, also known as UAPs. This week, there were no confirmed sightings of outer space aliens, Martians, UFOs, or UAPs. For the solar activity report, the sunspot regions, there's about 9 of them, very low magnitude. They appear to be very benign, so the sunspot regions are listed there on the graphic. And then the solar activity in the past few hours back when this data was gathered, you can see that very low levels of solar activity. So the solar activity appears to be pretty quiet. And that's your solar activity report for today. And now we go to the music segment. We always want to include some of the excellent space music that's being generated. So a fabulous song from 2034 by Spectral Valkyrie, Overman. Enjoy.
Monolithic moonstone, houses on my
So this segment is about robot development. And in this particular point, I'm not going to try to predict when robots are going to have sufficient manual dexterity or be able to perambulate well enough to do all human jobs. The point is just to keep an eye on the updates and developments as many new robots are introduced into the workforce. So the first one I'm going to play is snippets from the introduction of the Figure 02 robot, and it'll be without a whole lot of comment from me. Look at the hand motion, the implied dexterity, the ambulation as it walks, and realize that although this is an early point in its development, I don't think it's going to be too long before this is able to do a number of different jobs. Please keep in mind that this company was founded less than 2 years ago. Event Horizon Indicator Update on the grind towards the economic singularity. The economic singularity is an event in which humans lose their jobs to cognitive automation. Cognitive automation includes both bots and AI. I've devised an indicator equation that tracks a simple set of economic facts collected by the U.S. Federal Reserve and published each month. As this indicator moves closer to zero, we're getting closer to what I consider the economic singularity. I created this equation and graph because the discussion on the replacement of human labor by AI and bots has been too nebulous and vague. This provides concrete measurement of directionality. I'm going to indicate it in two ways, a symbol and a graph. The symbol is an ellipse in which the point at which you get to totality, when the dead moon completely blots out the vibrant sun. This total eclipse indicates a completed economic singularity. As you can see in the symbol, right now the sun, representing the human labor force, is not shadowed by the moon, which represents the onrushing advent of human-level intelligence in computer software, or in human-level dexterity in robotics. Now the graph that's shown here combines two factors. One is the U.S. male participation rate. The second is the U.S. unemployment rate. You can see over the decades this indicator has dropped consistently. You can also see that during the complete shutdown of the U.S. economy for the COVID pandemic, that this indicator briefly crossed the zero line. Therefore, it's important to point out that the indicator must remain below or at zero for an extended period of time. We're attempting to measure permanent technological unemployment. This is a secular change, not a cyclical moment in time. Summary: today, the economic singularity has not been reached. Not yet. OmniFuturist.
Robots in space.
everyone, I'm Mike DiVerde. I'm an aerospace engineer. Today you can see that I'm wearing my Space Station Freedom shirt. The highlight for today is the Hayabusa 2 mission to the Ryugu asteroid. This is a Japanese spacecraft that flew to, it was the first one to have landers on an asteroid. Some of the landers were made by the German Aerospace Center, DLR, and so we've got some interesting animations and videos. The focus, as I tend to do on these episodes, is I pick out a research paper of interest that was based on some of these robot spacecraft, what they've discovered, what they've brought back. In this case, Hayabusa literally brought back something from space. So it was a return sample from the Ryugu asteroid. And so we'll discuss what the mission is, what the little landers look like, what the material that was brought back, and what does it say about our solar system. So I hope you enjoy. Now I'll describe the JAXA, otherwise known as the Japan Aerospace Exploration Agency. I'll describe the JAXA Hayabusa 2 mission overview. On December 3rd, 2014, the Japanese space probe Hayabusa 2 embarked on a sample return mission to asteroid Ryugu. The animation depicts this mission. The Hayabusa 2 spacecraft returned the samples to Earth in a capsule that landed in the Australian desert on December 6th, 2020. Samples are now being studied at facilities around the world. The aim of the Hayabusa 2 mission is to learn more about the origin and evolution of the solar system, as asteroids account for some of the most primordial celestial bodies. Researching them gives us a glimpse into our cosmic past. The Hayabusa 2 spacecraft was the first to deploy operating rovers on an asteroid, first ever. Hayabusa 2 carried 4 small rovers to explore the asteroid surface in situ and provide context information for the return samples. Due to the minimal gravity of the asteroid, all 4 rovers were designed to move around by short hops instead of using normal wheels. The first rover, called Hibou, Hibou, and the second rover, called Owl, OWL, landed on asteroid Ryugu on September 21st, 2018. The third rover, called Mascot, was deployed on October 3rd, 2018. Its mission was successful. Mascot stands for the Mobile Asteroid Surface Scout, and it's a lander that was built by the German Aerospace Center, DLR, in collaboration with the French space agency CNES. The fourth rover, known as Rover 2 or Minerva 2-2, failed before release from the orbiter. This animation shows the full route of Hayabusa 2 with its lander Mascot from Earth to its encounter with Ryugu, the deployment of the lander, and how the lander relocates on the microgravity surface of an asteroid. It's very interesting. Ryugu is a carbonaceous chondrite. Chondrites are composed of chondrules. A chondrule is a round grain found in a chondrite. Chondrules form as molten or partially molten droplets in space before being accreted to their parent asteroids. Because chondrites represent one of the oldest solid materials within the solar system and are believed to be the building blocks of the planetary system, it follows that an understanding of the formation of chondrules is important to understand the initial development of the planetary system. Furthermore, Ryugu is a near-Earth asteroid, which means it could pose a threat to Earth and must be investigated in order to reduce this threat. This movie was taken on February 22nd, 2019, when Hayabusa 2 first touched down on asteroid Ryugu to collect a sample from the surface. It was captured using the onboard small monitor camera, CAM-H. The small monitor camera that captured this powerful video was produced and installed by donations from the public. Thanks to this camera, Hayabusa was able to photograph the situation during touchdown. I'm now going to discuss the research paper that was recently published based on the extremely rare Ryugu asteroid mineral sample, what the mineral analysis discovered, and the theory proposed to explain the results. The title of the paper is "The Nickel Isotopic Composition of Ryugu Reveals a Common Accretion Region for Carbonaceous Chondrites." The diagram shows two different points in time in the early development of our solar system. The Ryugu asteroid mineral sample appears to be from a particular class of carbonaceous chondrite asteroids, the Uvuna type Ci chondrites. This is based on the nickel-iron grains detected in the sample brought back to Earth. A chondrite is a non-metallic, stony meteorite that has never been modified by melting. Quoting directly from the paper, the Ci chondrites incorporated these grains more efficiently, possibly because they formed at the end of the disk's lifetime, when planetesimal formation was also triggered by photoevaporation of the disk. Isotopic variations among carbonaceous chondrites may thus reflect fractionation of distinct dust components from a common reservoir, implying Ci chondrites Ryugu may have formed in the same region of the accretion disk as other carbonaceous chondrites. What they're focusing on is the efficiency of certain processes in order to form these particular materials as opposed to other carbonaceous chondrites. That seems to be the key factor that they're driving on, is that it's not the location in the solar system, in the disk, that determines this type of carbonaceous chondrite. What determines it is what part of the process of the disk formation, the photoevaporation, is this material available in. And it seems to be that this particular form of iron nickel seems to be, because they're such small particles, don't seem to accrete into asteroids of other types of carbonaceous chondrites, only into this particular type. So here's my summary. Research paper uses traces of a special isotope of nickel in this asteroid to suggest how the early solar system formed. Now here's the key. This is kind of the point of the paper and why we would be paying attention to it at all. This class of asteroid seems to correlate with the sun's composition. Apparently they compare the photosphere on the sun, the materials that are in it, compared to what's in this sample that they brought back to Earth and analyzed. Okay, so this class of asteroid seems to correlate with the sun's composition, which means that JAXA may have recovered material that is unchanged from the time prior to the formation of our sun. That's a pretty interesting insight into before the sun even ignited. OmniFuturists.
Robots in space.
Hello everyone, I'm Mike DiVerde. I'm an aerospace engineer. Today I'm wearing my SpaceX Dragon shirt. I worked on the design for Dragon's second cargo resupply mission, CRS-2, which launched on March 1st, 2013. That mission took heavy thermal radiator grapple fixtures up to the International Space Station. Almost 20 years prior to my engineering efforts at SpaceX, I was a primary structure lead engineer for the Space Station Truss when I worked at McDonnell Douglas Space Systems in Huntington Beach, California. So this photo you see captures both of these space projects that I worked on, as the robot arm on the space station pulls the grapple fixtures out of the trunk of the SpaceX Dragon. On today's episode of Robots in Space, I'll discuss missions by 3 different spacecraft orbiting Mars: Mars Reconnaissance Orbiter, MRO, Mars Global Surveyor, MGS, and Mars Express Orbiter. We'll watch an overflight of an area of particular interest, Noctis Labyrinthus. Then I'll discuss findings from 4 different research papers. The overview for today's episode is like this. Water in fairly large quantities is being detected on Mars. Not only did water take part in creating Noctis Labyrinthus, this maze of irregular canyons could also be a likely place to search for native Martian life forms. However, the main point is that Noctis Labyrinthus would be one of the premium Martian equatorial locations for landing, exploring, and colonizing this planet. Someday. Mars Reconnaissance Orbiter was launched on August 12, 2005, and it reached Mars on March 10, 2006. In November 2006, after 6 months of aerobraking, it entered its final nearly circular orbit at approximately 155 to 196 miles, and it began its primary science phase. It is still operational on Sol 6676. Mission objectives include observing the climate of Mars, investigating geologic forces, and relaying data from surface missions back to Earth. MRO carries 3 cameras, 2 spectrometers, and a subsurface radar. Data from MRO has been used to choose landing sites for landers, to discover pure water ice in craters, and to determine that water once flowed on the surface of Mars. The shallow radar, SHARAD, sounder experiment on board MRO, is designed to probe the internal structure of the Martian polar ice caps. It also gathers planet-wide information about underground layers of regolith, rock, and ice that might be accessible from the surface. SHARAD emits HF, high-frequency, radio waves from the two rod antennas, which resolves individual layers as thin as 20 feet thick to a maximum depth of 2 miles. SHARAD is designed to complement the Mars Express MARSIS instrument, which has coarser resolution but penetrates to a much greater depth. Both SHARAD and MARSIS were made by the Italian Space Agency. HiRISE stands for the High Resolution Imaging Science Experiment, one of 6 science experiments. This instrument is designed to produce the most detailed pictures of Mars ever taken from orbit, revealing surface details as small as 3 feet across. The Compact Reconnaissance Imaging Spectrometer from Mars instrument, PRISM, is a visible and near-infrared spectrometer that is used to produce detailed maps of the surface mineralogy of Mars. PRISM is being used to identify minerals and chemicals indicative of the past or present existence of water on the surface of Mars. These materials include iron oxides, phyllosilicates, and carbonates, which have characteristic patterns in their visible infrared energy. The PRISM instrument was shut down on April 3rd, 2023. Mars Global Surveyor, MGS, was an American robotic space probe developed by NASA's Jet Propulsion Laboratory, launched on November 7th, 1996, and its primary mapping phase began on April 1st, 1999. MGS was a global mapping mission that examined the entire planet from the ionosphere down through the atmosphere to the surface. Mars Global Surveyor performed atmospheric monitoring for sister orbiters during aerobraking and helped Mars rovers and lander missions by identifying potential landing sites and relaying surface telemetry. On November 2nd, 2006, the spacecraft failed to respond to messages and commands. Attempt to recontact the spacecraft and resolve the problem failed, and NASA officially ended the mission on January 2007. MOC, Mars Orbiter Camera Science Investigation, used 3 instruments: a narrow-angle camera that obtained grayscale high-resolution images, and both a red wide-angle camera and a blue wide-angle camera for context and daily global imaging. MOC operated in Mars orbit between September 1997 and November 2006. And now, my favorite space science instrument of all time, Mars Orbiter Laser Altimeter, MOLA, which was designed to determine Mars' global topography. Look at that clear and obvious depiction of the high points and low points on Mars. Beautiful. Credit to Maria Zuber and David Smith for their laser altimeter research. This is the usual portrayal of the data, which presents a clear view of the entire planet from east to west and north to south. It operated as an altimeter until a portion of the laser reached end of life in June 2001. The instrument then functioned as a radiometer until October 2006. But look at this version with the data on the two hemispheres. Wow! As it is in three-dimensional space. Now, here is the area on Mars of prime interest, Noctis Labyrinthus. Translation is night labyrinth or night maze. To the west, you can see one of the Tharsis volcanoes, and to the east, the colossal Valles Marineris Canyon, largest ever in our solar system. Valles Marineris translates as Mariner Valleys, and this was named for the Mariner 9 spacecraft, which discovered it in 1972. This map provides critical data if you want to consider water flow in Mars' past. The height difference between the top of a Tharsis volcano all the way down to the bottom of Valles Marineris is about 12 miles, which is about 20 kilometers. Which is about 63,000 feet. See, you can imagine water flowing down slope from glaciers, paleo lakes, and groundwater as the Tharsis volcanoes began to rise in the west. The Mars Express Orbiter has been successfully performing scientific measurements since early 2004, namely high-resolution imaging and mineralogical mapping of the surface, radar sounding of the subsurface structure down to the permafrost, precise determination of the atmospheric circulation and composition, and study of the interaction of the atmosphere with the interplanetary medium. Arriving at Mars in 2003, 20 years, 11 months, and 24 days ago, which is about 7,525 souls. It is the second longest surviving, continually active spacecraft in orbit around a planet other than Earth, behind only NASA's still active 2001 Mars Odyssey. The MARSIS instrument is of prime importance. On May 4th, 2005, Mars Express deployed the first of its two 20-meter-long radar booms for its MARSIS experiment, which stands for Mars Advanced Radar for Subsurface and Ionosphere Sounding. Both 20-meter booms were needed to create a 40-meter-long dipole antenna for MARSIS to work. A less crucial 7-meter-long monopole antenna was deployed earlier. Nominal science observations began during July 2005, For reference, 40 meters is 130 feet. A very long and thin rod antenna. The radar altimeter was used to assess the composition of the subsurface to search for frozen water. Here is an image of subsurface water that was detected by MARSIS near the south pole of Mars. The MARSIS instrument was used to discover a large amount of subglacial liquid water on Mars. Quoting from the research paper entitled Radar Evidence of Subglacial Liquid Water on Mars, we surveyed the Planum Austral region using the MARSIS instrument, Mars Advanced Radar for subsurface and ionosphere sounding, a low-frequency radar on the Mars Express spacecraft. Radar profiles collected between May 2012 and December 2015 contain evidence of liquid water trapped below the ice of the South Polar layered deposits. Anonymously bright subsurface reflections are evident within a well-defined 20-kilometer wide zone centered at 193 degrees east, 81 degrees south, which is surrounded by a much less reflective area. Quantitative analysis of the radar signals shows that this bright feature has high relative dielectric permittivity, greater than 15, matching that of water-bearing materials. Here's the point. We interpret this feature as a stable body of liquid water on Mars. Now we will watch the excellent video from the Mars Express orbiter. Enjoy. So why is anyone interested in Noctis labyrinthus? For that, we need to listen to Pascal Lee, a fabulous researcher at NASA Ames and the Mars Institute. Let's look at his recent paper entitled A Relic Glacier Near Mars Equator, Evidence for Recent Glaciation and Volcanism in Eastern Noctis labyrinthus. The paper was written by Pascal Lee et al. 2023. Summary. A light tone deposit in Eastern Noctis labyrinthus presents distinctive morphologic characteristics of a glacier. Although the glacier is likely relic, the preservation of fine-scale glacial features opens up the possibility that water ice might still be preserved beneath the light-toned deposit material. Recent equatorial glaciation, volcanism, and volcano-ice interactions on Mars are implied. Noctis Landing is attractive to explore as it enables access towards the east to Valles Marineris and its extensive record of Martian geologic history to search for signs of past life, and towards the west to Noctis labyrinthus, the Tharsis volcanoes beyond, and their many lava caves to search for extant life. Hydrated minerals are present in Noctis Landing in a wide variety of forms among the many light-toned deposits in the area. Water ice fog has also been interpreted as a common occurrence in Valles Marineris and Noctis labyrinthus. However, there is as yet no evidence in this region of water ice in surface or near-surface materials in the current epoch. This is not surprising, as water ice would not be thermodynamically stable if exposed directly to current annual atmospheric pressure and temperature conditions in Mars' equatorial regions. Two possible current states are hypothesized. One, all the water ice is gone, but the light-toned deposit has formed a veneer preserving the glacier's morphology in relic form down to its finer details, such as crevasse fields. Or two, some water ice is still there, but it is blanketed by light-toned deposit material, which insulates it thermally and diffusively, as with ancient ice islands in Altiplano Salars. Pascal Lee et al. Wrote a short paper describing the advantages of using Noctis labyrinthus as a landing site entitled Noctis Landing, a proposed landing site and exploration zone for human missions to the surface of Mars. It was written by Pascal Lee et al. In 2015. So this predates the paper we were just talking about. Observe his map and consider his highlights. The relic glacier is not noted on this map, which predated the relic glacier paper, as I just said. However, I have added a large blue arrow that points to where I believe Pascal Lee identified the relic glacier of his other paper. The solid red circle marks the distance of 100-kilometer radial range from the landing site, which is the black dot at the center. White dotted lines represent potential paths for pressurized rover traverses. White solid circles mark locations offering potential resources such as water ice, hydrated minerals, iron, and sulfur-bearing minerals. Now, quoting from his research paper, the proposed site also contains regions of interest that offer the following resource characteristics. 1. Access to raw material that exhibits the potential to A. Be used as feedstock for water-generating in situ resource utilization processes, and B, yield significant quantities, like more than 100 megatons of water. C, the raw material is likely in the form of hydrated minerals and possibly an ice and regolith mix. The top of the raw material deposit is at the surface. Makes it easy to grab. Number 2, access to a region where infrastructure can be emplaced or constructed. This region is less than 5 kilometers from the landing site and contains flat, stable terrain. The region exhibits evidence for an abundant source of loose regolith. Several deep pits in the area, combined with the availability of sand, suggest that some natural terrain features can be adapted for construction purposes. 3, access to raw material that exhibits the potential to be used as metal feedstock for in situ resource utilization and construction purposes. Iron and sulfur-rich mineral surface deposits have been identified in CRISM data in many locations in this area. And here's just my aside. I think that there's an awful lot of iron and sulfur all over Mars, frankly. Number 4, Noctis Landing is the lowest altitude location on Mars that straddles both the Tharsis region with above average geothermal gradients and Valles Marineris with minimal crustal thickness from the valley floor to a subsurface liquid water table. So you got heat energy and relatively easy access to a water table. And 5, Noctis Landing has the potential for being an ideal site for eventual deep drilling on Mars to access deep subsurface liquid water and potentially encountering extant life. Everybody's looking for those Martian microbes. We've now arrived at the primary research paper, the final of 4. The main themes of the research paper, entitled Groundwater Flow Induced Collapse and Flooding in Noctis Labyrinthus, Mars. So here's kind of the first theme is groundwater flow and geological processes on Mars. The research paper discusses the role of groundwater flow in the formation and collapse of geologic structures in Noctis Labyrinthus. It highlights how groundwater flow from the Tharsis volcanic rise contributed to the evacuation of large basins and chasmata in the region. Chasmata is just a fancy way of saying multiple canyons, right? Chasm, chasmata. So the second main theme is catastrophic floods and aquifer systems. The research paper explores the hypothesis that catastrophic floods, driven by the evacuation of aquifers and ancient lakes, played a significant role in shaping the Martian landscape, particularly the circumcrisi outflow channels. The identification of hydrated minerals such as opal, gypsum, and sulfates within the basins of Noctis Labyrinthus points to past aqueous activity and the presence of water-rich environments. 23,000-foot elevation difference between Syria Planum and the floor of Tithonium Chasma suggests a significant hydrostatic pressure that would have been sufficient to drive large-scale groundwater flow and discharge. So now I'll quote from the research paper, Interpretive Synthesis. Formation and inundation of enclosed basins in Noctis Labyrinthus. We propose that the tectonically aligned troughs, pits, and enclosed basins of central and eastern Noctis Labyrinthus likely developed as a consequence of surface collapse over conduits generated by fault-controlled groundwater flows. So I'll have you look at figures 1A and 1B now. Our findings indicate that these flows sourced from an aquifer system in northeast Syria Planum and discharged into the floors of ancestral basins produced during the early rift stages of western Valles Marineris. And so now you want to look at figures 13A panel 1 and 13B. Theme 3 is geological evidence and remote sensing data. The study utilizes remote sensing images and topographic data from Mars Reconnaissance Orbiter and Mars Global Surveyor to map and analyze the morphometric and morphologic characteristics of Noctis labyrinthus. Quoting from the research paper, we have also identified numerous decameter scale landforms within this basin which, based on assemblage, comparative geomorphology, and the proposed paleolacustrine geologic context, we interpret to have likely developed in periglacial settings. These landforms include 1. Domes that locally exhibit summit pits. So I'm going to point out the figures to you. So look at the figure 6A for that, okay, for the summit pits, domes with summit pits, which we interpret as pingos. So look at figure 6B now. And by the way, a pingo, I had to look up, I've never heard of it before. It's a hill or a mountain that's got ice at the core of it. And so a lot of these things that we're going to describe here are things that you see on Earth in Arctic regions where the thaw-freeze cycle creates some unusual landforms. So anyway, pingos, right? That's in 6B. Continuing now. Or mud volcanoes. So that's shown in figure 6C. Number 2 is shallow irregular depressions. That's figure 6D. Which we interpret as produced by thermokarst melting. That's figure 6E and F. 3, patterned ground. And so look at figure 6G now, which we interpret as produced by expansion-contraction episodes associated with ice freeze, thaw, condensation, sublimation cycles. Now you're going to look at figure 6H, or by sediment desiccation, figure 6I. As observed in terrestrial polygons developed in ice-rich permafrost regions and salt playa lake environments, the documented Martian polygons range from a few to about 20 meters in diameter. Fourth theme, hydrated mineral deposits and lacustrine features. The document identifies the presence of hydrated mineral deposits and features indicative of ancient lakes and periglacial processes, suggesting a history of aqueous activity in the region. Quoting from the research paper, the presence of widespread hydrated salt deposits within the central Noctis labyrinthus basin is in agreement with a conduit origin linked to the dissolution of regional upper crustal salt deposits, aided perhaps by suffusion resulting from groundwater flow along regional faults extending across buried, unconsolidated sedimentary deposits. We interpret the ridges that mark the northern and southern margins of basin, and you're going to look at figures 3D and 3E, as possible lacustrine paleo shorelines that were likely produced as sediments that were pushed outwards during expansion freezing cycles of the lake's surface. And now you want to look at figure 3F. Fifth theme is the astrobiological potential. The findings highlight the potential of Noctis labyrinthus as a prime region for astrobiological exploration due to its long-lived integration of subsurface and surface hydrologic environments, which could have been habitable. Quoting from the research paper now, the long-lived integration of subsurface and surface hydrologic environments, perhaps enriched by nutrients, by hydrothermal processes, could have favored the development of potentially habitable environments. Therefore, this region of Mars comprises a prime candidate for astrobiological exploration. These themes collectively contribute to an understanding the geologic history and potential habitability of Mars, particularly in the Noctis labyrinthus region. Here is a very clear diagram of what the researchers are proposing for the water flows on Mars that created much of Noctis labyrinthus. So if you look at figure 13, panel A, sketches illustrating the proposed model for collapse and inundation in central and eastern Noctis labyrinthus. One, this is you look at the left-hand side, the figure at the top there, groundwater flow dominated by a radial trend from Serioplanum to ancestral basins in western Valles Marineris generate extensive systems of nested conduits along pre-existing faults. So then you go to the second sketch down. Collapse over excavated conduits forms enclosed basins in central and eastern Noctis labyrinthus. Third sketch down is the floors of the basins accumulate widespread lacustrine sediments and lavas. And then the fourth, the bottom sketch, surface erosion associated with eastward large-scale mass flow discharges results in the merging of eastern Noctis labyrinthus basins and Tithonium chasma. Tithonium chasma accumulates large volumes of sedimentary deposits, including possible lacustrine materials. If you look at the right there, panel B, the very interesting diagram there. MOLA, remember that's the laser altimeter, MOLA shaded relief map showing the proposed drainage paths of an aquifer in Serioplanum. And then the red shading and blue arrows show the inferred flow directions. The aquifer's approximate location is marked by the blue shading. So here is my summary of the researchers' hypothesis for the creation of Noctis labyrinthus. Number one, ancient Mars had huge lakes and underground groundwater reservoirs. Then the Tharsis volcanoes began to rise, and the elevation of the surface created a downslope for water to flow. And the magma that supplied the Tharsis volcanoes provided heat to melt surface glaciers. So two is there's a potential that magma chambers that were previously in the Noctis labyrinthus zone emptied, creating collapsing colossal caverns. So they got squeezed out. So as the volcanoes rise in the west and heat up the above ground glaciers, the ground begins to collapse under Noctis labyrinthus. Another potential mechanism is that the surge of water flows underground through the salt-rich deposits, dissolving them. Either separately or in concert, the magma chambers or the salt deposits create caverns, and then the previously flat surface collapses into what we now see as Noctis labyrinthus. OmniFuturists.
Robots in space.
Hello everyone, I'm Mike DiVerde and I'm an aerospace engineer. In today's superluminal episode of Robots in Space, we will discuss the latest updates from Curiosity and Perseverance rovers on Mars and the latest weather there on Mars. Curiosity is driving through quite difficult terrain on sols 4398 to 4401. Sols, you might recall, are just a different name for Martian days, which are almost the same length as Earth days. Earthlings controlling the rover use Martian days so that the drive takes full advantage of the sunlight. Sol 1 is the day a particular spacecraft lands on Mars. The image gives a good impression on what the rover is dealing with. Lots of rocks embedded in sand. I think even hiking would be quite difficult there, let alone driving autonomously. Curiosity, thanks to our excellent rover drivers, makes it successfully most of the time, but here and there, Mars just doesn't play nice. Thus, the rover stopped after about 46 feet of a planned much longer drive. One of the wheels had caught a low spot between two rocks and, safety first, the rover stopped and waited for our assessment. The rover drivers found no major problem, as it's just the middle wheel that hit a bit of a rough patch. Perseverance is now in Grosmorn Quad, named for a beautiful Canadian national park in Newfoundland. For the drive ahead, our next destination is on the lower western edge of Jezero Crater Rim at a region named Witch Hazel Hill. Much of the climb up the crater rim was on sandy material without many rocks to analyze. Witch Hazel Hill appears to have much more exposed rock, and the science team is excited about the opportunity for better views and analyses of the geology directly beneath our wheels. Now I want to give a shout out to the great experts in photogrammetry, the hard science of using photographic images to create a complete picture, a group named Unmanned Spaceflight for their helpful advice and guidance. Paul Hammond of this group provided this excellent description. As the crow flies, the rover is still about 130 meters from the base of Witch Hazel Hill. The hill is west-southwest of the rover's current location, and the base of the hill is 15 meters lower in elevation compared to the current location of the rover. The team did not acquire high-resolution images of the location after the drive on Sol 1380, so I'm assuming that it's likely that the rover will drive again on Sol 1381, unless the team spots something interesting in the fractured bedrock in the rover's current workspace. The location Witch Hazel Hill is shown on this map from JPL. The blue line on the map is the notional route the rover planners have selected many months ago. Those notional paths are subject to change as better targets are spotted or easier paths are spotted. So again, that was on Sol 1380. Now we'll see some map work by Steve Albers, another member of the Unmanned Spaceflight Group. His description is, here's a very unofficial map showing some nearby features present in recent imagery. And here is Steve Albers' excellent mosaic from Sol 1363. And now for my favorite part, which is the Weather on Mars report. Curiosity is taking daily weather measurements at Gale Crater in the southern hemisphere of Mars near the equator. At this location, it is currently early autumn. On Sol 4410, which is January 1st for Earthlings, the high was -4 degrees Fahrenheit, and the low was -101 degrees Fahrenheit. OmniFuturists.
Robots in space.
Hello, everyone. I'm Mike DiVerde, and I'm an aerospace engineer, and more importantly, a fighting Illini. In today's superluminal episode of Robots in Space, we'll discuss the latest updates on bot tech and the current standing of our proprietary indicator for the economic singularity, the Event Horizon Indicator. As I did previously with the Figure 02 robot, I'd like to make a minimal comment on this bot tech development for the Sanctuary AI bot's hand. The most obvious bot feature that currently differentiates the various humanoid bots is dexterity. Literally billions of tasks that humans do every single day depends on our 10 fingers. So, some of these bots have useless paws. Others rival human hands. And to me, the first and most obvious application is pick and place at places like Amazon warehouses that are already highly roboticized. Quote, dexterous capability is directly proportional to the size of the addressable market for general-purpose humanoid robots, unquote, says James Wells, interim CEO and CCO. Sanctuary AI announces its latest breakthrough with hydraulic actuation and precise in-hand manipulation, opening up a wide range of industrial and high-value work tasks. Hydraulics has significantly more power density than electric actuators in terms of force and velocity. Sanctuary has invented miniaturized valves that are 50 times faster and 6 times cheaper than off-the-shelf hydraulic valves. This novel approach to actuation results in extremely low power consumption, unmatched cycle life, and controllability that can fit within the size constraints of a human-sized hand and forearm. We'll now discuss the graph and equation that I developed to measure our progression towards the economic singularity, the Event Horizon Indicator. The value for November 2024 is 93.8, which is the lowest in 3 years. You can see that the trend has been steadily down lately. I'll remind you that when the indicator, epsilon eta, reaches zero and remains below zero, that indicates that we've finally reached the economic singularity with very low labor participation rates coupled with high unemployment due to the bots taking the jobs. The eclipse indicator symbol shows that the eclipse has just barely begun, but it has begun. The Event Horizon Indicator is derived from two impeccable data sources provided by Federal Reserve Bank of St. Louis. This is the data for U.S. male labor force participation rates since 1948. Do you notice a trend? And this is another data source provided by Federal Reserve Bank of St. Louis. This is the data for the U.S. unemployment rate since 1948. That huge spike in unemployment in 2020 is the Trump recession, where the Event Horizon Indicator briefly dropped below zero, but recovered swiftly under the Biden American Rescue Plan. OmniFuturists.
Robots in space.
Hello everyone, I'm Mike DiVerde, and I'm an aerospace engineer. Today I'm wearing my Ghost in the Shell shirt. Today's episode of Robots in Space, I will discuss the purpose of the OmniFuturists Group and what we're up to in addition to this podcast. I formed the OmniFuturists Group in 2022 primarily because I'd read an excellent book by Callum Chase entitled The Economic Singularity that talked about a new near-future problem in which artificial intelligence and robotics were more cost-effective than human labor, and therefore almost all jobs were given to cognitive automation. The problem, of course, is that without a job, most people would be homeless, starving, without proper medical care, and then they would die miserable and young. I read several other books that discuss this dystopian future as a possible outcome, but I did not come across convincing or serious descriptions of how this might be handled. There seemed to be a lack of plans on how to deal with this. Part of the problem is that many people do not believe it's a likely event, so why spend any time working on something that is never going to happen? Some people think that they'll be exempt from this situation because they have special skills and knowledge that a robot or machine intelligence could never acquire. The reasons why we do not have serious plans for this possible future are not important to me. What is important to me is that a series of options are described and evaluated. Now, at this time, there is increasing political strife and a complete unwillingness to compromise or consider alternatives. There are a few political tribes, and they are applying a political purity test to everything. No one attempts to even consider alternatives. Everyone retreats inside their clubhouse and talks with people within their own echo chamber. I'm attempting something that is fairly rare. I'm trying to intentionally gather a group of people who have wildly different political and economic preferences. I'm trying to get them to respectfully listen to alternatives and consider the pros and cons of all of these potential solutions. And this perspective is where the prefix omni comes from. I literally want all possible alternatives to be considered. Nothing is disallowed. Now, I have my own perspectives and expectations and my own preferred solutions, but I listen to them all. There is a possibility that as we develop as a nascent think tank, that we will develop a concrete evaluation methodology. I like the Delphi method, for example. But we aren't there yet. We're still gathering a variety of options from all over planet Earth. Last year, we published our first book entitled Future Visions. We're just about to release our second edition, and we stayed with the original title. So now we're about to publish Future Visions 2025, with an almost all new series of chapters from a variety of authors. I will have a series of short interviews with each of the authors. The first book had 12 chapters with 12 different authors. The second book had 14 chapters with 14 different authors. And I believe that we kept only a single chapter from the first book in the second book, so the material is almost all fresh. Each of the authors is going to answer the same series of questions. I'm going to answer my own questions about my own chapter from the original Future Visions here today. Now I will pose the same questions that I plan to ask each of the authors of the chapters of Future Visions and answer for my own chapter. A self-interview, which my beautiful wife Julie thinks is just a hilarious idea that I would interview myself. Okay, so the first question is, do you think that the economic singularity is likely to occur in the next 10 years? If not, when, if ever? I am certain that the economic singularity will occur within 10 years. Actually, I expect it prior to 2030. So I think that we have only about 5 years maximum left. How would you define the onset of the economic singularity? I have developed my own equation and graph to measure our progress towards the economic singularity. Basically, I felt that the discussion was too nebulous and that a concrete, trackable equation and graph and measure could objectively indicate what was happening. It is a very simple measure that is based on two publicly reported numbers. The crux of the economic singularity is the replacement of human labor with cognitive automation. That has everything to do with job loss. We have two well-known measures in America of job loss: labor force participation rate and unemployment. The data for both of the factors are provided by the U.S. Bureau of Labor Statistics, and I retrieve them once a month when they are provided by the St. Louis Federal Reserve Bank. So, once per month, I will be updating this indicator and publishing the results. These factors measure different things. Labor force participation rate shows a long-term engagement by the workforce. I'll point out that I only use the U.S. male labor force participation rate due to the rise of female participation in the paid labor force over the decades. The data that is available begins in 1948. In 1948, the female paid labor force was vanishingly small. Over time, of course, women appeared more and more in the paid labor force. This growth was independent of automation or lack thereof. This was a changing culture in which it became far more accepted for an adult single woman or a mother to engage in a full career throughout her life. People who are not part of the active labor force and do not show up in the labor force participation rate have given up long-term on finding suitable employment. It is a long-term measure. On the other hand, the unemployment rate shows people who have, unfortunately, fairly recently lost their job and are still expecting to find a good job soon. My understanding is that after about 6 months, most people drop off the ranks of the unemployed and they're no longer counted at all. So, my equation uses both the U.S. male labor force participation rate and the U.S. unemployment rate. I looked for levels that were relatively extreme in both measures. Although the target level of unemployment is 2%, we see levels up to 7% relatively often. The unemployment level has a variation with the economic cycle. The worst case unemployment rate was a 25% unemployment rate during the Great Depression. I selected a 10% unemployment rate as a significant indicator that the economy and the labor force had changed fairly dramatically. The labor force participation rate for men has been dropping since 1948, but it has taken 70 years for it to drop 18%. A dramatic change in labor force participation rate would be a further 18%, but not over a 70-year period, but over the next 5 or 10 years perhaps. So the equation is written from current levels so that it will reach zero once both the unemployment rate reaches 10% and the U.S. male participation rate reaches 50%. Now, there are other combinations of unemployment and participation rate that can cause this measure to drop below zero. But that's probably not that critical. A slightly higher unemployment rate or a slightly lower participation rate is not going to change the verdict on the arrival of the economic singularity. There's one more important condition. This indicator must remain below zero for a relatively long time. We've already had one flash below zero in this indicator during the Trump recession. That simply reflected an abysmal economy that was being mismanaged. That did not stem from the onset of widespread cognitive automation. That was the result of incompetence in our federal government. So I've named this measure the Event Horizon Indicator. The symbology that I'm using is a solar eclipse, which in normal conditions the moon does not cover the sun. Once the Event Horizon Indicator reaches zero, then the symbology will be a total solar eclipse. You see the graph of the Event Horizon Indicator behind me. How do you think that humanity should deal with the economic singularity? Well, I'm going to focus the question on America because I really don't have a good understanding of how the rest of the world should or would deal with this. Within America, I'm very pessimistic that our federal government would properly prepare to house and feed 300 plus million Americans. So I'm framing my answer on the expectation that for many years people are on their own. I expect that, as we do today, the homeless will have a very difficult time getting shelter, the hungry will have a very difficult time finding good food, And those who cannot afford medical insurance have an extremely hard time getting a doctor to work with them on their health issues. So what I would advise Americans to do is to gather in small groups on small farms and create co-ops to provide their own food on a survival basis. This is not a glamorous solution. I think it's a dirt poor survival solution. I've done enough very rough calculations that I'm convinced that either a universal basic income is too small an amount of money to make a difference, or it is enough money per person to make a difference, but the US federal budget could never afford it. Universal basic income is a deception, a pacifier, and a distraction that's going to keep people from preparing properly. Do you think that we will ever achieve superabundance? I absolutely believe that we will achieve superabundance. I'm counting on artificial superintelligence coupled with cognitive automation to deliver a well-developed plan that provides enough for all, and I mean all. I expect that we'll go through a horrible period of the economic singularity, which will be alleviated by an inspired solution from an artificial superintelligence that can reach beyond the greed of the current oligarchy. Are you concerned at all about the arrival of artificial superintelligence? Oh yes, I'm concerned about the possible variations in artificial superintelligences. I'm hoping that there are a series of these and that at least several of them are in possession of a good character and good morals. I think that there will be some that are completely evil and that will be encouraged to continue the wealth pump from the working class people up to the oligarchy. What other topic is first and foremost in your mind? For example, space travel and colonization, or super longevity, or crypto, or geopolitics, or quantum mechanics and quantum computers, etc. Well, robotic space travel is first and foremost in my mind. I think that it is too risky at this point for humans to travel in space. I don't think that we have characterized all of the significant risks of death and terminal illness from the space environment. I would like us to spend the next couple decades sending robotic spacecraft out to completely characterize the radiation and microgravity and chemical characteristics of some of the nearby moons and planets before we try to send too many people out there to die. Once we not only understand the risks, but we also have developed wonderful technologies to protect humans, once they are beyond the beautiful protection provided by planet Earth's magnetosphere and atmosphere, then it'll make sense to start sending people out to permanently live on other planets and moons within our solar system. OmniFuturists